make sure that we are all on the same page to get ready for the test tomorrow. Okay, so the first three, we are just identifying what property or theorem or postulate is happening. So in number one, it says if A is the midpoint of QR. Okay, so on something like this, it's be helpful to sketch out what's going on. So we're saying that A is the midpoint of Q and R. Then that means that these two segments are the same. Okay, they're congruent to each other. Well, the reason we're allowed to say that is that's just what it means to be a midpoint. Right? If I have a midpoint, then that cuts the segment in half. So number one is definition of midpoint. Okay, now if we're told that something is a midpoint, usually we're going to use definition of midpoint at some point. Right? Number two, more algebraically. Okay, so we're given an equation. Okay, PQ equals RS. And then if I look at the next step, we're adding the same thing to both sides of the equation. Okay, I'm adding XY to both sides. So if I'm adding the same thing to both sides of the equation, that is the addition property. Guys, what are we doing? We're doing a review right now. For number three, I'm told that the measures of two angles are equal. Therefore, those same two angles are congruent. Okay, if I'm going back and forth between two things are equal, therefore they're congruent, or vice versa. That is the definition of congruence. Now for the next two, we're filling in lines on a proof. Okay, we're missing a couple of pieces. So on this one, we're given three things. Okay, we're given AC bisects angle BAD and AC bisects angle BCD, and angles 1 and 2 are congruent. So they fill all that in for us, and then they say, well, then we could say angles 1 and 3 would have to be the same. Okay, so they're claiming these two angles would have to be the same. And then they're also claiming angles 2 and 4 would have to be the same. So I can put the same number of arcs in those angles to show that they're congruent. So if I look back at what I'm given, okay, line 1 says AC bisects angle BAD. So bisect means to cut exactly in half, okay? Meaning that the two halves will be congruent. Same thing for line 2. We're told AC bisects angle BCD, meaning the two smaller angles that are created would be congruent. That's just what it means to be a bisector. Okay? If we're given information about a bisector, usually at some point in the proof, we're going to use definition of an angle bisector. So the reason we're allowed to claim that these two pairs of angles are congruent is because that's just what it means to bisect something. Right? When we cut it exactly in half, the two halves are the same. So now, in line 5, they claim, well, that means angles 3 and 4 would have to be the same. Okay, and they actually kind of did two steps in one here. Okay, what they did was, they said, well, if angles 1 and 2 are the same, then I could plug angle 2 into here. Right? And then, if angles 2 and 4 are the same, then I could plug 4 in place of 2 over here to get angles 3 and 4 would be congruent. So what they did was substitution, or we could actually use transit. Okay. We okay with those? Okay, so remember on the test tomorrow, all of the proof questions will be in multiple choice format, but you will not get a reference sheet. So you're going to want to look over your reference sheet when you're studying for the test. So the next, numbers 6 and 7 were actually kind of reviews from previous sections. Okay, number 6, we are just asked to name a plane parallel to STU. Okay, if you remember, back in the first chapter, we named planes using 3 points. Okay, so STU is actually referring to this whole plane here, the whole top surface. So, yeah, so the bottom plane would be the one that's parallel. So we can name the bottom plane also using 3 letters. Okay, so sure, we can name it CYW. That would work. Well, if it just says name a plane.
No. That's
Oh, okay. Gotcha. So there are a couple other correct answers for number 6, though. We could name it using any 3 points on the bottom, right? We could call it. Yeah. Right. So now. All right. Make sure you're on it is for Joe. For number 7, then, as Kodak just told us, these 2 angles would be equal to each other. What's the name of the relationship between these? Vertical. These are vertical angles. So we always set vertical angles equal to each other. So the setup would be 5x equals 2x plus 24. I would subtract 2x over to the other side. Then divide by 3. You get x equals 8. Is that my final answer? Yeah, it is, because it just says find x. Okay. You okay with those?
I didn't get 8 or 9.
Well, let's take a look at 8 and 9. So on both of these, we're using this figure here. So the first one, we're just given numerical values. So I'm told that these 2 lines are parallel, and angle 8, which is right here, is 86 degrees. And from that, I want to find angle 13. Okay, so this is the one I want to find. I can ignore this half of the diagram, and I'm just looking over here. So first, if I wanted to name this relationship, what's the name of the relationship between angles 8 and 13? What is it? Not corresponding. So they're on the same side of the transversal. They're both on the inside of my parallel lines. So that one we called consecutive interior. Right? If they're on the same side of the transversal, both on the inside of the parallel lines. And we said consecutive interior angles are always supplementary. They add to 180. So if I want the measure of this angle, I would just take 180 minus 86 and get that this angle is 94. Okay, so that's the answer for number 8. Angle 13 is 94 degrees. Then for 9, we're given some expressions. So we're going to have to set up and solve some equations here. So I'm told angle 4 is 6x minus 5. And then I'm told angle 10 is 5x plus 8. So these 2 angles here, okay, the name of that relationship would be alternate interior. So alternate interior angles are always equal to each other. So I can say 6x minus 5 equals 5x plus 8. So subtract 5x over, get x minus 5 equals 8. Add the 5 over, and we get x equals 13. Okay, so now I'm told angle 9, which is right here, is 3y minus 10. So now I need to use that value of 13 to figure out what y is. Right? So I can plug 13 back into either of these values. They're going to be the same.
Do the 6th one.
Do the 6th one? Okay, so if I plug it in here, 6 times 13 minus 5 will be 7. What is that? 78 minus 5 is 73. So 73 degrees. So what that means, I can essentially erase this 6x minus 5 and say this is 73 degrees.
And then that's 73 degrees too.
Yeah, so then this one would also be 73. So now,
180 minus 73.
so yeah, what we're going to say is, I can eat, right? So if I do 73 plus 3y minus 10 equals 180, okay, what? Essentially that's 180 minus 73, right? But I can combine my like terms and get 73 minus 10 would be 63 plus 3y equals 180. Subtract the 63 over. 3y equals 117. Divide by 3. And what is that, 59? Alright. Questions on that one? Okay. So then number 10, we are just naming the relationships between these angles. So angles 1 and 8, these two angles right here that are right next to each other, they share a side and they make up a straight line together. Okay? Two angles that make up a straight line together that are right next to each other are a linear pair. Angles 2 and 4. Okay? This angle and this angle. Yeah, I got the first one's linear pair. So now angles 2 and 4 are corresponding. They're in the same position, just on the other of the parallel lines. So corresponding here.
Let me know what I can say the other one.
Okay. So angles 6 and 7. Okay, those two angles are here and here. So they're on the same side of the transversal, on the inside of the parallel lines. So they're interior, and they're consecutive. So we would say consecutive interior. And then our last one, angles 3 and 7. So this one, this one. Your favorite one. Why is it your favorite one?
I actually like exterior better than
Like to be on the outside. Okay, so there will be questions on the test tomorrow just asking you to name relationships between angles. So make sure that you study those. You know what the names of the relationships are. Okay. Now the next few, we are determining whether lines are parallel, perpendicular, or neither. Okay, so once we get into this stuff, okay, this was where Desmos may be helpful. Right? So you will be able to use Desmos on the test tomorrow. Okay? So I'll do these by hand. Okay, and then we can double check on Desmos. So what we want to do is find the slopes of these lines, right? I want to find the slope of QV and then of RS. So my first slope of QV, remember always label your points, x1, y1, x2, y2. So my formula, y2 minus y1 over x2 minus x1. So I get 12 minus negative 8 over 5 minus negative 3. So 12 minus negative 8 would be 12 plus 8, so that's 20. Over 5 minus negative 3 would be 8. And then we always want to reduce. So 20 over 8 does reduce. 5 over 2. So let's do the same thing. Let's do the same thing for RM. So label x1, y1, x2, y2. So I'll have 2 minus 1 over negative 5 minus negative 2.5. So that'll be 1 over negative 5 plus 2.5 would be negative 2.5. So it looks like there's no relationship, right? It looks like we got 5 over 2 and then 1 over negative 2.5. Those two things don't look the same at all, right? They don't look the same. They don't look like they're reciprocals. But if we use the calculator, right? If I put in 1 divided by negative 2.5, I guess I can bring up the calculator here. Okay, you guys know how to use the calculator to simplify fractions? Okay, so I guess I'll show you that here. Okay, so follow along on the calculator so you get the buttons down here. All right, so if I wanted to take that 1 over negative 2.5, okay, I can just put that in as a division problem. I can do 1 divided by negative 2.5. Okay, yeah, and it gives me a decimal. It gives me negative 0.4. Well, if I press the math button, which is on the left side of the calculator, it's the third one down. Okay, everybody see the math button? The first option says frac. Okay, that's going to turn a decimal into a fraction. So choose that first option. I can okay, now I can say, well, I've got 5 over 2 and negative 2 over 5. So this one's perpendicular. Okay, these two numbers, 5 over 2 and negative over 5, are opposite reciprocals. Okay, these are going to be perpendicular. So if we ever get funky numbers like this, okay, when we find a slope, we want to use the calculator to simplify. Okay, that way we can compare our numbers nicely. Okay, so this one is going to be perpendicular. So if we take a look at the next one, 12, I want to do the same thing. I want to find the slope between Q and B, and then the slope between R and M. So that'll be 4.5 over 4 plus 2 is 6. But again, we got a funky decimal. Okay, I want my fractions here to be nice whole numbers. So I'm going to use the calculator again. Okay, to get a nice number. So if I do 4.5 divided by 6 gives me a decimal. Okay, and then if I use math frac, so math and then the first option, it'll turn that into a nice fraction for me. So x2, y2, so I will have negative 1.5 minus negative 12 over 10 minus, oops. It's going to be the same thing, right? So I got 0.75 the first time, got 0.75 for this one, but we can double check and use math frac and see that being, we can double check our answers using Desmos, right? If I just plot all 4 of these points, okay, and then draw lines between Q and B, a line between R and M, we should see that those 2 lines end up being parallel. Okay, so use Desmos to make sure that your work makes sense. Right? So now on number 13, okay, 13 and 14, we want to start writing equations of parallel and perpendicular. Okay, so on number 13, I'm going to write the equation that goes through the point 6, negative 1 and is parallel to this line. Okay, so remember, the formula that we're using is y minus y1 equals m times x minus x1. Okay, make sure that you know this for the test tomorrow. Okay, know this formula. So we need to collect three pieces of information, right? I need x1, y1, and m. M is the slope. So if I want my new line to be parallel to this line, okay, first of all, what's the slope of this line? Y equals 3x minus 7. Slope is 3, right? So if I want my new line to be parallel, what's my new slope going to be? 3, right? Parallel means same slope. So if this is my point that I want the line to go through, this is my x1 and y1. So I'm going to plug this. I'm going to have y minus negative 1, so that'll be y plus 1, equals 3 times x minus 6. Okay, and then it says we want our final answer in slope. So I'll have y plus 1 equals 3x minus 18. And then subtract this 1 over, and we'll get y equals 3x minus. Alright. So we also talked about a way to do this on Desmos. I hesitate to use Desmos. And I'm actually going to bring Desmos up and do that here. So, maybe. There we go. Alright, so I want my new line to go through the point 6, negative 1, right? And my old line was y equals 3x minus 7. So I want a little bit. So I want my new line to be parallel to my old line. Okay, so if I'm looking at this graph, over 1, I can go do the same thing in the other direction. And I'm just going to do that until I get to the y-axis. So I can see where this line would cross the y-axis. If I draw that line, it ends up crossing the y-axis at 19. So the equation of this line would be y equals, so the same slope, 3x, then minus 19. Yeah, our goal is to write a parallel line. Yeah. The next one, okay, number 13, we want to write the equation of a perpendicular line. Okay, so original line just goes, okay, we're not given an equation. Okay, so I have to do y2 and find the slope between those 2 points. So I'm going to have negative 3. Alright, so negative 3 minus negative 2 would be negative 3 plus 2. That'd be negative 1 over 1 minus 3 would be negative 2. So if I've got a negative over a negative, that's going to be a positive 1/2. So the slope of my original line is 1/2. I want my new line to be perpendicular. So what's my new slope going to be? Negative 2 over 1. Okay, so this is my old slope. My new slope is going to be negative 2 over 1. And I want my new line to go through this point right here. So this will be my x1, y1. So again, I'm going to plug this information into y minus y1 equals m times x minus x1. So my y1 is negative 5, so y minus negative 2x plus 3. So this line would be perpendicular to AB. Okay, and we can double check that. Okay, I can plug in and make sure they're perpendicular. So let's do that. So what were those 2 points? 3, negative 2, and 1, negative 3. So if I put those in, and 1, negative 3. Okay, so if I draw a line between these 2 points here, okay, this line is going to do something like this. Then if I graph what we found our perpendicular line to be, y equals negative 2x plus 3. Okay, I can see that those two lines end up being perpendicular. Okay. Questions on those? All right, then on the back, okay, we're dealing a little bit more with our parallel relationships. So on number 15, we are just told that angle RNM, so is this angle right here, that angle is congruent to SPN. Okay? So I'm looking at these two angles here. They're both on this transversal up here. That means that these are the two lines that would be parallel. Okay, so it asks for two pieces of information, right? State which lines are parallel, and then why. So what I would say first is the two lines that are parallel would be NR and PS. Right? These are the two lines that would be parallel. And then I have to say why. Okay, so I want to state the name of the relationship between these two angles. These two angles would be corresponding angles. So I can say because corresponding angles are congruent. Okay. You okay with that one? Alright, so then the next few, bless you, we're just setting up and solving equations based on the relationships in the picture. So in this number 17 here, I'm looking at these two angles. Okay, there's an arrow showing that 4x minus 1 is this angle right here. So the relationship between these two angles, okay, these are consecutive interior angles, so that means they would add to 180. So my setup is going to be 12x minus 11 plus 4x minus 1 equals 180. Combine my like terms, so I would have 16x, negative 11 minus 1 would be negative 12. Add 12 over. Get 16x equals 192. Divide both sides by 16. And what is that, 12? In number 18 here, I'm looking at alternate exterior angles. So these two angles are going to be equal to each other. Okay, alternate exterior angles are congruent. So my setup would be 9x minus 44 equals 6x plus 10. So I would subtract 6x over, add 44, and then divide by 3. So that gets me 18. Okay. Then on the next one, okay, which is also number 18, this one we just kind of had to think about what the problem is saying. Okay, it says we're given a line, and xy is 6, yz is 4, and xz is 2. So if we're thinking logically here, the distance, the largest distance would have to be the 2 points that are farthest apart, right? So if the distance between x and y is 6, and then I can say 19 and 20, I'm using this diagram. So on number 19, I'm told angle BFC, which is this one right here, is 70. Then I want to find the measure of angle EFD, this angle right here. Okay, well, we can start filling in angles all the way around until we figure out a way to do it. Okay, so if this is 70, this angle makes a straight line with angle 70, so this would be 180 minus 70, that'd be 110. Okay, well, then we could also say these two angles are vertical, so this would be 70. And if this is 90, okay, we could say, there's two ways we could do it. We could say these three angles would add to 180. So I could do 180 minus 70 minus 90 is 20 degrees. Okay, or we could say if this angle is 90, or if this angle is 90, then this angle is 90. So 90 minus 70 is 20. The last problem just asks us to set up an equation here. So I'm told angle AFE is 5x minus 10, and angle BFC is 3x plus 20. So those two angles are vertical angles. That means they would be equal to each other. So my setup would be 5x minus 10 equals 3x plus 20. If the x is on one side, the numbers onto the other side. Divide by 2, and we get x equals 15. And that is my final answer, because it just says find x. Right?